another class. I'm Dr. B, your chemistry teacher. And today we are going to be taking a look at iron and the chemistry of rust. Iron and the chemistry of rust. Do not forget that in this class, you have to subscribe to this YouTube channel, or you have to share this class and tell those you are sharing it to subscribe as well. You also have to leave a like, a comment, even if it's a question, we're going to attend to you. Now you also have a Facebook page, Dr. B Chemistry, Dr. B Science Classes, Dr. B Science Classes. You go there and also follow. You share it and ask those who are also sharing to do what to follow and like, and also leave comments as necessary. All right, today we are going to be dealing with iron and the chemistry of rust. Now, the question is iron. I hope you know that iron come also in different forms and that alloys of metals are made up of iron. Example, steel. You know that steel is iron and it's an alloy. It has almost 98% composition of iron. And it also have carbon steel as well. It also has iron and have other type of alloys that come with iron with them. And all metals that have iron, and even those that do not contain iron, undergo rust. They present rust. Now I hope you also know that iron is a transition metal, and as a transition metal, iron has some characteristics. As a transition metal, iron will always show variable oxidation states. It shows variable oxidation states. Iron also shows some element of complex formation, complexes, and then it also produce colored compounds. Okay, so those are qualities of transition metals, and iron as a transition metal possess those qualities. Iron having variable oxidation state means that iron can exist in +1, 2, and +3 state. And the process of iron losing electrons from +1 to 2 or from +2 state to 3 states shows that iron can possibly undergo what? Oxidation reaction, because it is oxidation reaction that give iron the opportunity to do what? To leave from one of its lowest oxidation, oxidation state to the next oxidation state. And in that way, it loses what? Electrons. Now, why do iron rust? That is the most important thing. When you have your key with you, why does your key suddenly start rusting? When you have a nail around you, why do nails suddenly start carrying some sort of brownish coloration? Okay, some sort of brownish coloration. Why do they have those coloration with them away from how they used to be normal? So you pass around, you see pipes, you see roofs like zinc, you see other kind of metals getting rusted. But why they rust? Why do metal rust? The question is, must metal rust? Must iron rust? And the answer is yes. Iron must rust. Iron supposed to rust. Iron have to rust. Now I'm going to tell us why it is first. Now I'm going to give us a little picture of what happened around iron as a metal, or steel as a metal, or other alloys of iron. Now do you see that if you have a pig is an animal. If you have a pig around you, a pig is always dirty. Do you know that when you bet a pig and decides to allow the pig goes back to the dirt. It goes back to the dirt and carry mud all around it. But why? Because a pig naturally is meant to be dirty. A pig feels and knows that naturally it's meant to be dirty. You are the one who need it to be clean. So a pig will always want to be dirty to be at its natural state. That is what happened with iron. Why iron rust? Because originally iron in its thermodynamically stable state is rust. Alright, so if iron has to be as it's supposed to be, naturally as it's supposed to be, thermodynamically stable as it's supposed to be, then iron should be existing in a rust form. So you are the one, I am the one who wants iron as a metal to be clean. So at any given opportunity, iron is unstable, is not happy, is uncomfortable at that clean state. So it will always want to go into oxidation to return to its rust form, where it is its natural form. So you and I will always want the iron not to be in its natural form. So that's why I say it is a yes. Iron must rust, because that is the state to which iron is supposed to be naturally and thermodynamically stable. Fine, but how does this rust come about? Take a look at the drawing that we have on the board. How iron rusts. The process to which iron rusts. Do you know that before iron rusts, a metal rusts, there must be a presence of oxygen and water? That if there is no presence of oxygen or water, you can never have iron or any metal at all go into a rust form. So whenever you see your key that you carry along rust, it means that it's either you generate heat in your palms that creates some moisture around your key that reacts with the oxygen and metal that allows it to rust, or you have allowed water or rain, for example, to fall on you and on that metal or the key, thereby allowing oxygen to act with the water and allow the metal opportunity to do what? To undergo oxidation reaction. So for every rusting process, there must be oxygen and water. And do you know that rust is a product of corrosion? And corrosion is an electrochemical process. That means there must be an existence of an anode and a cathode and an electrolyte for corrosion to take place. And when corrosion thereby takes place, then the product of that corrosion is the rust that you find around your metals. Now, corrosion as a process, we say is electrochemical. Even as an electrochemical, it is an oxidation reduction process. And that is why when you take a look at this particular diagram, you see the anode, which shows always where oxidation takes place. Oxidation takes place. And you see what? The cathode, where reduction takes place. Where reduction takes place. So the process, the reaction that happens between a metal like iron, for example, with what? With water and oxygen is an electrochemical reaction. It is an oxidation reduction reaction. The nail forms the what? The anode. And if the nail forms the anode, then the oxygen coming in will definitely become part of your cathode. And in the anode, oxidation takes place. And that is why, for this nail to get rusted, it must lose electron. So when it loses electron, it becomes oxidized. In that way, it will do what? Have the opportunity to react with oxygen and water to yield the rust that you see around your keys, or around your nails, or around your metals, even those in your cars. So now, the nail will serve as the anode, and oxidation will take place there, and at the cathode, oxygen is there to act as the cathode, and reduction will take place there. That is, there is what? Gain in what? Gain in electrons. And then you have water, which plays the role of an electrolyte, or what? A catalyst. Water plays the role of electrolyte because with the help of electrolyte, there is what? There is an expedition of what? Of the removal of electrons from what? The ion or the nails to the solution across to the oxygen. Remember that the oxygen has what? 8 electrons, and that is what? 2:2:4. So it still have what? The 2p4, the 2p orbital, where you have 2px, 2py, and 2pz. So the 2p x is filled, the 2p, y, and z are not filled. So there are 2 electrons that are remaining there to be paired. So the oxygen, the ion, the nail here will definitely lose electron to the oxygen that is electron deficient, and it will accept the electron as a cathode. And this particular reduction of electron, which is oxidation, is what leads to what? Leads to the rust we are talking about. And once it comes in contact with water, the next thing you find in the nail or the iron is that what? Is that brownish coloration that you see and you call rust. And this is usually iron 3 what? Hydrated iron 3 oxide. That is rust. Hydrated iron 3 oxide. Now, we are going to put this away and look at the chemical equations that lead to rust, because when you see your key get rusted, it is not just about the rust you are seeing. There is the chemistry behind it. There are reactions that have happened. We are going to take a look at those reactions. Alright. Now let us take a look at those reactions that happen along that particular route of rusting. And remember, those reactions are reactions along corrosion line, because rust, as I said, is a product of what? Corrosion. Now the first thing that will happen, we said there is always what? There is always oxidation. There is always oxidation of iron metal. We say there is always oxidation of iron metal. And if there is oxidation of iron metal, it means that the iron is going to be losing what? Electrons. Now, that means we have iron losing electrons to give us iron 2 plus 2 electrons. This is the first thing that will happen. As iron loses electron, it oxidizes at the anode. Okay, and then since the iron is serving as the anode, oxidation takes place there. It loses electron there, and we have this equation. So 2 electrons are lost there. It is oxidized to what? Iron 2. Now, after that, it reacts with water. It reacts with oxygen. So we look at the reaction with oxygen. We look at the reaction with oxygen. We look at the reaction with oxygen. So it means that at this point, iron 2 will react with oxygen as gas and also react with water. This will leave us with what? This will leave us with iron 3, okay, plus the hydroxide ion. So this is it. At this point, this is the beginning of rusting on your metal, key, or any other thing, even on your car ions or metals. So the first thing is the oxidation reaction, reduction of what? Losing of electrons by the iron metal. So it loses electrons, and you have iron 2. The iron 2 will now react with oxygen and some amount of water. Okay, and when it reacts with it, it is going to be further what? Oxidized to iron 3. And this iron 3 is what will now have its third reaction, where we have 4 of iron 3 reacting with 3 molecules of water, of oxygen, gas, and reacting with an unknown amount of water, and that will give us iron 3 oxide with an unknown amount of water. This is what you call rust. And this is the greenish coloration that you see on your metal or iron or whatever it is. And this is hydrated iron 3 oxide. And hydrated iron 3 oxide is the greenish coloration you find covering your iron or metal that you call rust. And this is the process that leads to rusting, that leads to the rust that you have. And like I said, it is an electrochemical process, an oxidation reduction process. Okay, so this is how it happens. So the first is the oxidation reaction, which is the losing of electrons from iron, which we have iron 2 now. And iron 2 will now do what? Iron 2 will now further react with oxygen, which is the second reaction, with a known amount of water or moisture. And this will give us iron 3. Iron 3 will now react with more of the oxygen, and then with an unknown amount of water to give us a hydrated form of iron 3 oxide. The hydrated iron 3 oxide is your rust. That is how rust come about. Do you know that you can protect your iron, your metals from rust, at least once you are able to fight the corrosion to some level, to some significant level, you can also be able to eliminate rust, because rust is a product of what? Of corrosion. Now, for you to be able to fight rust, the first thing you have to do is you may have to do coating of your metals. You coat your iron, you coat your metals. When you coat them, you will be able to what? To reduce the corrosion, and it means that you invariably reduce what? The loss of electrons from what? The metal. Now, the second way you can also try to protect these metals is by barrier method. Okay, by barrier method. You can use barrier method in also protecting your metal from rust. Barrier method means you can do oiling. So you can use oil to, to rub on your metals. You can use greasing by using grease on your metals. Okay, even your keys. You can do painting. You can probably use oil paint in painting your metals or painting your iron or whatever. You can use galvanization method. You can galvanize them. Then another method you can also use is sacrificial protection. Okay, you can use a sacrificial protection. You can use sacrificial protection. In sacrificial protection, it's simple. What you need to do is look at the metal that is highly reactive than iron. For example, if you look at the electrochemical series, zinc is highly reactive than iron. So you can use zinc to coat your iron. Instead of the iron to be rusting, the zinc will be what? Will be rusting. So the zinc now is serving as a sacrificial anode instead of the iron. There are many other methods, but these are the three cardinal methods you can use in protecting your metal from getting rusted. I'm sure you've enjoyed today's lectures on iron and the chemistry of rust. Do not forget to subscribe onto this channel. Do not forget to also share, and when you share, tell those you are sharing the channel to subscribe and tap the bell as well, and that is going to bring these lectures popping up at any time they are uploaded. Don't forget that the channel is Dr. B Chemistry or Dr. B Science Classes. You go to also Facebook, you're going to find that part there, Dr. B Science Classes. You just need to follow, share these classes, and as we are sharing with, to follow, like, and comment. Leave your questions there. I will do justice to them immediately I see them. For now, it is bye.